Okay, so we will look at concrete modular as I was telling you. Modular buildings and modular homes are essentially prefabricated building or houses that consist of repeated sections called modules essentially. So, it is actually a as we shall see it is 3-dimensional module, simply 3-dimensional module, right, 3-dimensional module. So, complete thing that you will be constructing actually in the sections, obviously full section away from the building side, and then you install the prefabricated section and complete at the side. Obviously, they will be you will be using cranes. So, this is the casting of such a module, right. Actually, you place them side by side. So, they are very suitable for places like where there are repetitive rooms, similar kind of rooms, say hotel construction and hostels. So, there are similar modules are there in the house, I mean apartments or repetitive ones, hotels or hostels, and allowing variety of course configuration styles. So, but it would be varieties of styles is possible, and you can insert insulation and reinforcement straightaway at the site itself. So, they would possibly look something like this. This is a casting of a module, casting of the set of. So, you have got a number of actually casting, not a single bed, number of casting bed. For each module there will be one bed. There is a kind of reinforcement placing. So, then once the cage comes in, the whole thing comes in, there is a formwork and then you do the concreting. So, precision is definitely required, right, and repetitiveness, although they are at a given location. So, you need number of repetitiveness, and the cage is you put it using a crane, and once placed then do the concreting. The rebar placing is done something like this, and then do the concreting straight away. So, it is basically pumped concrete. Self compacting concrete can be very easily used in this kind of situation, and you do the casting. So, 3D modules with self compacting concrete, obviously strength has to be high because section will be thin, and it must take all handling load. Actually, more crucial is the handling load. So, minimum 40 MPa concrete is what is required. So, then this is transported, whole module is being transported, lifted up, and ceiling cast simultaneously with a monolithic module. So, everything is cast in one go. So, it is monolithic, even structurally it will act all together. So, structural stability from point of view, it will act all together, therefore, the performance is better and you can save on to material. So, cured to lifting strength, minimum strength is required and then transported. Then obviously, this gives you faster construction process. There is much less waste generated in this kind of system. Monolithic, hence strong, durable, and you can make multifunctional system. So, you can use more sustainability this kind of system. Material consumption is much less. You can add on to any kind of insulation or similar sort of thing. So, thermal performance or energy performance you can have better, and in the long run it will be cheaper, because after a certain number of modules, that is one thing, break even point, but since it is you can built in design it according to your requirement of climatic requirement. So, long run life cycle cost will be lower, better quality control. So, therefore, sustainable, you can design, sophisticated design is possible. You can use lean construction methods, which in construction technique the methodology they use, and some cases it might be possible doing 3D printing. Now, what is 3D printing? 3D printing is nothing. This is a kind of technique which has come more from the electronics materials industry using robots and then polymer molding. Now it is being attempted in concrete as well. So, what you do is you have a robotic arm with an extruding nozzle. So, the concrete will be placed layer by layer, so you built it up. So, a 2-story concrete, continuous concrete, not masonry like, but then just concrete, maybe reinforcement, or you can put in reinforcement and you put that concrete. So, what should the robotic arm do? It will just go through like this, put the concrete by layer, extrude through extrusion process, although I am not discussing in detail this 3D printing. So, you can make this sort of thing through 3D printing as well. Obviously, top slab, there will be a gap between the top slab casting and the rest of the thing, because all the walls will be cast layer by layer. So, you can build it. So, you can use 3D printing and building information modeling software you can use to visualize how the construction, it can, all those techniques can be easily applied. So, that is what it is. Obviously, transportation is you have to take care of the transportation, and therefore, damages during transportation and energy during transportation, both. So, damages has to be taken care of, and then you spend some energy during transportation. So, that has to be taken into account. So, this is what it is. So, that is what, for example, concrete modular, a building. This is multi-story modular housing block in London, December 2005. So, this is all modular precast modular concrete blocks. So, you see they look all similar, that is the thing, repetitive units. So, each unit is repetitive, and right. So, it is a housing block, this is of course a housing block. So, they precast the whole thing, take it out and put it there. One can give this finish formwork in the formwork itself, and that is what it is. So, that is the concrete modular concrete, that is the last in the concrete line, but we have something in the steel also, something in the steel also. For example, as I was telling you, light gauge steels. So, this is cold formed, that is what I was mentioning in the last class actually. Long thin sheets are guided through a series of rollers to bend and shape the steel into strong C or Z sections. So, you can have sections like this or sections like a channel section C capable of holding heavy loads. So, this actually work hardened steel. You have already given some permanent deformation, it has come between the rollers, number of rollers, and you have several passes. So, thickness will reduce after each pass. Material is same, that means you have densified it or you have actually work hardened it altogether. Then you might galvanize it with zinc or zinc and aluminum. Obviously, the steel cannot be exposed on its own, because it will have a tendency to corrode, it will get oxidized very quickly. Now, zinc is used as a sacrificial material there. So, what will happen is zinc tends to oxidize faster, preserving the steel below. That is why this has been used more than few hundred years, or zinc and aluminum, which are more what we call anodic than the iron. So, this will get oxidized and protect the steel. Now, zinc when gets oxidized, it forms zinc oxides, and in presence of water it may become zinc hydroxide, and atmospheric carbon dioxide, through atmospheric carbon dioxide it might become zinc carbonate. So, they call it what is a patina formation, patina formation, which actually is a dense material. So, actually zinc carbonate would be formed at the top layer, because when this is galvanization means it actually gets into the steel, diffuses, a part of it diffuses into steel. So, there is an interfacial layer, then pure zinc layer, and there's at the bottom you will have pure steel layer. So, the top zinc layer, which finally forms a kind of zinc carbonate, which is very it's a stable, relatively stable material and do not get destroyed so easily. Eventually it will get destroyed, or thickness of the most of the zinc could get converted, and eventually there can be, it will take longer time. So, that is the use. So, therefore, steel you cannot use generally in bare form, usually section 100 or 150 millimeter with 50 millimeter flange or 1.3 millimeter flange, you will get 50 millimeter. So, something like this 50, 100 to 150, right, and then thickness obviously is very thin, because it has been compressed in a way, passed through the roller. It was actually originally thought to replace wood, right. It was originally thought to replace wood, but because of its flexibility, fast construction and durability, so it is quite high potential, something like this. So, this is the depth of the web, C section for example. This is the flange, there is a lip also you can have, and this is the thickness. So, this how is of course, I mean basically all prefabricated thing, and then essentially making building frames out of this. So, you can have studs. Basically, this is a some kind of finishing, right, cladding you can have, and this is the vertical members, and frame of steel structure is first you then construct, and then clad with dry sheeting. So, that is what is needed. So, you got to clad this on both sides to form a load bearing or non load bearing wall system or roof system similarly. So, this is the steel members, this is the final cladding that you see. So, that you can choose. So, so basically essentially platform frame system is what is used. Connection between the members are made with self tapping or self tapping screws. So, between members these connections can be screw type, basically thin members. So, you can have threaded screw system or bolt system to cover this. You can have pre-punched section with factory made holes on them for ducts, wires, plumbing, etc. can easily pass through this. The gap between the filler, so this in between you put in the insulation. So, steel member, in fact, there are 1 or 2 organizations actually marketing them in India, and we have a small building in the IT campus where we use this light gauge steel, small building, right. So, for measurement purpose, temperature and everything. So, gap between members are filled with insulations, and this is what it would look like, right. Wall cladding, then this is actually your floor level. There is a C section, there are other C sections here. Then you will have fiber cement floor or whatever you want, the type of flooring you want, which will be at the top, right. So, or you can have timber tiles, something like wooden structures earlier that we used to do, place the beams, closely spaced beams, and then top of that there is a cladding. So, it has been replaced by C channels. So, wooden battens which were used, ideally the idea was to replace the wooden battens, and these are light gauge. So, therefore, weights are not very large, and then you have the cladding. So, and then somewhere you will have joints, the fiber board or whatever it is. There can be other kind of finishes, for example, some kind of, depending upon the type of decking you want, you can put insulation or whatever the form of decking that you want, you can do that. So, timber and granite, this is a granite floor finish, and this is a timber finish, and this is how it looks like. So, light gauge still so wall and flooring and floor system and finishing. So, they have high potential, in that direction, that they can also perform multifunctional performances it can exhibit, and you can bring in all. So, this is many places in North America, Australia and Japan, they have been using this actually, right. So, this is, you can have pre-punch sections, sections with factory made holes, so that wires can pass through them. Also, since it is a frame system, you can adjust doors, windows, etc., locally at those places wherever you want. This is what another place is showing. For example, you can have precast concrete inside. So, you can have precast concrete. So, this is your light gauge steel frame, part of the frame, and you can have actually or concrete system inside, and precast concrete panel, and fill in infill and so on. So, there are varieties of possibilities are there. This is the frame, this is cladding, and in between you can put in concrete if you want to make it heavier. And obviously, concrete has the one issue would be related to fire. So, the cladding must save it, cladding must perform in such a manner that the steel is protected from the fire, because as you know, steel is vulnerable to fire. Unlike two problems with the steel is, one is the corrosion, which of course is taken care of by galvanizing. Fire is the other issue. Fire is the other issue because steel beyond 550 degrees centigrade, normal mild steel, it loses its strength significantly, right. So, it will start warping and form in fact hinges. So, this is one point, the steel is vulnerable to fire, it is a good conductor. So, the fire, it is exposed to fire at one point, all other points it will transmit the heat very easily. But if the cladding normally, for example, gypsum board cladding, gypsum is calcium sulphate 2H2O. So, this ones when subjected to fire, it absorbs heat and it gets actually this order of crystallization will go away. So, and then remaining calcium sulphate, anhydrous calcium, it will become anhydrous calcium sulphate. Remaining, what remains after losing this water, which absorbs a lot of heat, and whatever is remain, the anhydrous calcium sulphate is a good insulator also. So, this itself is a good insulator. So, the insulation property, fire properties of this one is very good, and that is why we use gyp board, and you will find that gypsums are used. So, also the concrete which has got a large mass, thermal mass, in the sense that rho c, and therefore, it will not allow it transmitted from one side to the other, or it is a good insulator. So, generally concrete, the steel are encased in concrete. Here of course, you are not, you can encase them or keep it in the manner that you like. So, essentially here there is a cladding and the concrete, you can encase this. So, fire properties are enhanced in that manner. So, infill or fire properties. So, building frames, low rise, it looks something like this, right, it looks something like this. So, you can see that these sections are C section, and then there is an inverted C section. So, the flooring system can be constructed in that manner, and light allow quick building without heavy tools or equipment. Every component can easily be carried by hand, and like a carpentry. So, basically the idea was to replace the timber, that was the idea. So, therefore, it is all from that side. So, generally you need to force, you go to join by screws. So, that is what all it needs, and since it is steel is strong, light gauge structures are lighter than wood frame structures and equivalent strength. So, it is much stronger than wood, therefore, much less material you can use compared to wood of course. It is able to shape itself to any form and can be clad and insulated with wide range of materials. It is easy to change or modify this construction at any point on its lifespan, because you can remove any one of the independent member and then replace them. So, that is light, That is what the main problem is, this fire. It must be protected from fire with fire rated sheeting, that is one thing. Protection is to clad the steel and fire rated, fire rated sheeting or dry wall. So, that is what it is. So, passage of sound more readily, that is also a problem, because sound travels, sound I mean the insulation quality, sound insulation quality of steel is not so good. Although because you got it's thin section, it is related to mass per unit area. M, which is M is kg per meter square in terms of kg. So, insulation quality is proportional to mass per unit area. Now, here thickness is very small, therefore, its insulation quality will not be good. Besides that, through the steel sound can pass easily. Through air it cannot pass, but through steel it can pass easily, right. So, that is therefore, you have to take care of that, right. So, modular construction, so this is so these issues are acoustic issues are important. So, what you can do is you can, depending upon the situation, you can actually introduce wherever there is a connection, might introduce, for example, if this is if there is an issue of acoustic transmission. So, between these two might put some other material, which is a kind of resilient material and things like that. So, you have to take care of this, So, for example, something called floating construction, where you have at essentially what we do is, in this one you might have a timber placed in between. Now, here you have to put in some kind of a resilient material. So, one has to keep that in mind, fire and this kind of problems obviously is there. Okay. You can have modular construction of this. So far we talked about framed construction, individual members, linear members. So, modular construction, factory produced pre-engineered building units straight away, right, that are delivered to site, assembled at large volumetric components as a substantial elements of building. So, off-site modular construction with light steel, that is also possible, like concrete. So, modular units may be complete rooms, parts of the room, or separate highly serviced units such as toilets, lifts, etc., etc. So, you can see that this is, like as you see, these days there are portable boxes that are used in construction sites, but people have constructed buildings with this kind of scenario, of course, the larger ones. The collection of discrete modulars usually forms a self-supporting structure on its own. So, therefore, you stack them one over another. So, it is made of steel, right. For tall buildings may rely on an independent structural framework. So, you can have a structural framework and then put them also, but otherwise for low rise building or something of that kind, you can have simply modular steel boxes, steel spaces made, 3-dimensional space modules made, prefabricated, lift it up and put it at the site. For example, this is what it shows, a crane just putting the one module straight away. So, very useful again for similar where there are repetitive units like hostels, hotels and even apartments. So, simply one can put them straight away the module, right. Yeah, of course, I did not include it here, but there is something called top down construction. I did not include it here, but top down construction, what they do is they will lift the, quite useful for office, construct the shaft, right, construct shaft which will be the lift shaft or something of that kind, inner core of a multi-story building, and this can be done through slip forming rapidly with continuous casting. Then from this you support lifting system, cast the whole floor at the ground floor level, can be of steel concrete composite system, cast the whole floor, construct, cast, so steel concrete composite system, decking, full thing you can cast, including furnitures, everything you can put in. Then this is lifted up straight away and placed here. So, all casting is done at the bottom, and you can have maybe 2-3 towers and complete building can be cast in this manner. It is pretty fast construction. Besides, you can actually bring in a lot of again multifunctional issues here. So, the next floor will be cast here, then it will be lifted up, including furnitures, they lift it up. So, the whole office is ready, like the Intel R&D center, new building they were casting about a year back in Bengaluru. So, it was 7 stories. So, they had actually number of lift wells, I think is 6 or 7. So, it is a L-shaped building. So, they did this is 5, maybe 5 or something, I do not remember exactly how many of them are there. So, first construct this lift shaft, which would take about 2 months, slip forming, and then support the lifting system right on the top, cast the deck here, cast the like whole floor here, and lift it up straight away. So, it was expected to complete a 7-story building in 9 months time or something. So, that is another kind of form of so can be this one, since it uses very low quantity of material, all of them, and wastage generated is very limited, therefore, they can add to sustainability. Anyway, advantages of light kilns is economy of scale through repetitive manufacture and rapid installation. So, that is then again you need a break even number, because you have to have set up factory basically. So, high level quality control in factory production and low self weight leading to foundation saving, suitable project with site constraints and where methods of working require more off site manufacture, it is advantageous there. Okay, there will be disruptions in the surrounding is very limited, right, and even in renovation projects, supposing you want to rooftop extension, we are considering, let us say construct 1 floor above the block 4, so it is 3 storied, rest some of them we will see they are 4 storied. So, you can use this because it is lightweight. You can actually build in acoustic insulations here due to double layer construction. So, basically if you see the section, somewhere, you can make it double layer, I hope it is there somewhere, somewhere. So, basically it is this all these are double leaf, and you can build in insulation there, and therefore, since you can built in insulation, so you can actually get thermal as well as good acoustic insulation. Future extension is very easy, because these modules are there, you got to add on both sides, right or left side, whichever, or top, whichever side you want. Okay, if you attach the units together, right, then they will be, all kind of their structural behavior will be synchronized or together. So, therefore, you achieve what is called robustness, right. So, the issue should be otherwise there, will the slide during earthquake or wind. So, this can be actually taken care of by some kind of attaching the units all together. Stability of tall bending is provided by brazed steel core. So, you can have a brazed steel core and suitable for building with multiple or repeated units, right. Size of units is limited to transport, of course, how much you can transport. So, 3.6 meter, 8 meter is typical. So, this is by 3.6 meter by 8 meter, that is the typical type of thing. So, open sided units can be created, supposing you want to keep one side open, that is possible by changing the floor orientation and so on. And modules are stacked with usually no independent structure, generally you do not need a structure, but you can do that. Self weight about 1.5 to 2 kilonewton per meter square, and good for 4 to 10 story building, right, 6 stories or something of that kind. Now, fire resistance can be provided by providing again good fire resistance coating or some sort of cladding has to be there. Well, fire resistance is you generally define in terms of time. It is the time for which the element can withstand standard fire defined by some time temperature relationship. Standard fires are defined in terms of time versus temperature as a function of time. So, typically the standard fire used for normal fire is 345 log 8T plus 1. Log of 8T, T is the time in minutes, and this is T delta T, temperature rise, or you can call it T minus T ambient is equals to 345 log 8T plus 1. So, this is a furnace temperature and it is subjected to such temperature. If it withstands for 30 minutes, then we call the fire resistance as 30 minutes. If it withstands for 60 minutes, then we call fire resistance as 60 minutes. So, that is why you would have seen here it says typically you can have 30 to 60 minutes fire resistance. This issue always remains whenever you are using steel, the fire issue is always there, and acoustic insulation is provided through double layer walls and floors. So, thermal and acoustic layer. So, therefore, one wall, another steel, and you can have insulation in between. And if you have, that is what I said, cellular type of buildings such as students' residences, workers' accommodation, even apartments, that has been done. So, but that should be basically cellular type of building, repetitive units should be there. So, generally walls should be C sections of typically 75 to 150 mm depth, floors 150 to 250 mm depth C section again. So, you may construct the floors with that. The difference is earlier you would have used light gauge elements fabricated at the factory and erected at the site. Now, even if the building module you actually completed the factory and transport it. So, longitudinal walls are usually load bearing and end walls provide for stability. So, longitudinal load bearing wall also can be there. Ceiling is manufactured in a similar way as we said. One sided modulus can be created by longitudinal floors and ceiling joists. End walls becomes load bearing then. So, walls are usually long walls are load bearing, the other one is just a supporting system. Open sided modules use deeper floor joist or lattice. So, if you have one side open, then you have to design this, you have to have it accordingly, and stability is provided by cross flats or diaphragm action of the boarding. So, corridor zones can be used to provide in plane bracing in long, sometime you can have bracings to provide extra stability. Double skin white for excellent acoustic insulation as I said, and floors also acoustics, you can put in mineral wool or some sort of lightweight material which will act as an insulation. So, four sided modulus, partial one sided modules, open sided modules, both sides open, modules supported by primary structural frame. Now, supposing you made a structural frame and then put in the modules, then they are obviously not the part of the structural system, they are supposed to take their own loads. Non-load bearing modules, mixed modules and planar floor cassettes, special stair or lift modules, so varieties of modules are possible. So, this is what is the factory, at the factory the lifting. So, this is process of course corner, floor, the individual members are here, right, C sections, and insulation in the walls, insulation in the flooring system, typical construction, and then once fabricated they can be lifted up, transported, right. So, once lift they can be, this is a 4-sided module of course is showing, and you can lift them up. So, single line of modules is something like that. Bracing requirements, no additional bracing in this one. Typical maximum stories, 3 stories if you are doing, you do not need bracing. If you are doing 5, then you need some additional bracing. If you are going to 7, then you have some longitudinal stabilization core, and minimum number of modules in a group, double line modules with, so you can have this kind of modules. So, construction, the arrangement of this one can see. So, you can see you have a corridor and the modules on those sides, again bracing requirement etc., are given. So, typical building height depending upon stabilizing system using 4-sided module, general, it's a general guidance. So, such system can be designed, and this is a 4-sided open system. So, you have just vertical members and there is the floors. So, open sided module, completely open sided module. So, you can have varieties of module forms and mixed combinations could be there. Judicious use of these combinations can provide good constructions. So, you see this can be combination module supported by long spanning cellular beams. So, this is a long spanning cellular beams, that means there are holes in this one, right, to create open space at lower levels of the module. So, that is what it is. So, there are these lower levels, these are like this is one type of modules, the other is the other type of modules at the top, and that is what it is. So, one can have varieties of combinations of the whole thing. In this one the frame is there already, then the module is supported by the frame, and installation module behind external, first steel work has been produced, frame you create, then you put in the module. So, key issues that are there, obviously you have to have dimensional planning, stability and structural integrity, service interfaces, acoustics and fire performances. So, these are the major key issues, and typical dimensions of planning in modular construction. Okay, internal wall height could be 2000 in study, bedrooms, apartments, hotels and so on. Width of the module, internal module length and ceiling floor zone etc. typical in millimeters, ceiling to floor the height, and in the ceiling floor zone, basically ceiling in the floor zone, ceiling and floor height could be something of this kind. So, this is this is what it is, even hospitals and so on, you can offices. So, they can be used, constructed, used. This is the typical wall dimension. So, you have got the this is a gap, then there could be optional board, and this is insulation, this is insulation, there can be board, and then steels on the other side, the steels is there. So, 300 overall including the light gauge steel, and this shows that floor dimensions, you can have a ceiling joist somewhere here, and then joist supporting this board system, this is the insulation, there is another joist and so on. So, one can build in all this kind of thing put together in in the modular units that is there. So, key issues of course, as I said, fire safety, good thermal insulation is there, and sustainability issues can also be taken care of. So, that is what this kind of advanced construction techniques which can make it sustainable. One issue is that they are using much less material, but initial cost is relatively high. So, if this has to be done, taken up, then you must have sufficient market available for this kind of construction, and that is the thing. Then the economics will work out, otherwise economics will not. So, if you have some questions, we will look into it.